Well, I had finally got my camera to work. I just had to turn my computer off and back on. It wouldn't turn back on at first, so kind of had a little worry of what do I do now? So I am so sorry about that the computer was kind of acting up, but it's just how it is. So what I'm going to do is I'll just make a video of the different questions that I think you'll need help with. If there's one you need extra help with that I didn't go over, please let me know, and I will if I can get the Google Meet to work, maybe I can do like a personal Google Meet with you after school or something. So I'm sorry about the technical difficulties. That's just part of this virtual world that we're in. Okay, so, all right, so I see that the first question is word and expanded. We should be okay on that. Then we have find the sum. Find the product is next. I'm still having a few people missing this. I know at home you may get to have a little extra help. So just make sure, remember when you're doing 58 times 45, you're doing 58 times 5 first in that first section. Put your placeholder, and then 58 times 4 beside it. So this is the product of 58 times 5. This is 58 times 4. And then you'll need to add those products together, and that's how you do that one. Okay, so next, let's see. And since I didn't get to see who logged on, I know 3 people were logged on when I was trying to get it to work, I'll just go ahead and put this, the one that I do with you, available to everybody on Google Classroom. All right, each 4th grader was asked to buy 4 boxes of crayons for the class. If each box of crayon holds 295 crayons, how many crayons did each student buy? It's a lot of crayons. So we got 4 boxes, each with 295 in them. And we want to know how many crayons. It seems like an unreasonable amount of crayons for one kid to buy, but so you would need to add 295 4 times, or do 295 times 4. Okay, so I'll type that in. All right, so find the GCF of 56 and 42. This is where you have to list your factors for 56 and 42. I will do this with you because this will probably be one my kids in class will need help on. Remember, GCF stands for greatest common factor. I dropped my computer. It's probably why my camera's not working, because I keep dropping my computer. All right, so 56. My first 2 are going to be 1 and 56. I know 56 is an even number, so 2 will have to be 1. Now, what times 2? You'd have to divide to see. 2 goes into 5 2 times. 2 times 4 equals 4. 5 minus 4 equals 1. Bring down your 6. And then 2 goes in 16 8 times. So 2 times 28. 3, well, 5 plus 6 equals 11. So 11 can't divide by 3. 4, I don't really know if 4 can. So I'm going to check with division. 5 goes into 4 once. 4 times 1 equals 4. 5 minus 4 equals 1. Bring down that 6. 4 goes into 16 4 times. So 4 and 14. 5, no. 6, no, because 2 is, but 3 isn't. 7, yes. 7 times 8 equals 56. So let me write those factors down that I just listed. I have a very squeaky desk. Okay, so 42. Let's check that one out. We got 1 and 42. It's an even number, so 2 will have to be a factor. Let's see how many times 2 goes into 42. 2 goes into 4 twice. 2 times 2 equals 4. 4 minus 4 is 0. Bring down your 2. 2 goes into 2 1 time, so 21 times. All right, 3 actually would be a factor because 4 plus 2 equals 6, and 6 can divide by 2. So I know 3 is a factor. So let's see what times 3. 3 goes into 4 once. 3 times 1 equals 3. 4 minus 3 equals 1. Bring down the 2. 4 goes into 12 4 times. So 3 and 14. 4 times 10 is 40. No. 4 times, let's see, 5. No. 6, yes, because 6 and 7. Okay, so let's write those factors down. Okay, so if I look at the factors that are in common, I see the biggest factor that's in common would be 14. So my GCF is going to be 14. And I'm making a copy of this for all my virtual kids because it's not your fault that my computer was being ornery. All right, so then we have the adding the fractions. So this is what we are doing this week. It's actually pretty easy. Now, I'm going to still do it with you because we haven't had a full-out lesson with this, or you guys haven't had to have that yet. So what you're going to do first is you're going to actually add the whole numbers, 3 plus 5 to get 8. The denominators stay the same. You do not add the denominators, but you do add the numerators. 7 plus 4 would equal 11. Now, I am going to teach this week how to turn that into, it doesn't look right. It's improper. That's why it looks kind of funny. So the way to think of this is I see that there's 10 pieces in the whole. So 10 tenths would be 1 whole. So I'm going to take 10 tenths out. And if that's 1 whole, I'm just going to give it to that 8 to make it 9. And then how many do I have left from here? If I took 10 tenths from 11 tenths, I would have 1 tenth. So 9 and 1 tenth would be my sum. Okay, so now on that subtraction, I'm going to show you how to do that. But this week, my in-class students are we're going to be using a lot of drawings to see how this works. So let's do this. Let's do 3 and 1/8. Let's draw that out. So there's 3 holes. The denominator tells you how many pieces are in the hole. So I see that 8 is my denominator. So I'm going to split these into 8 pieces. I know 8 pieces make the whole. So it's 3 holes, but there's 8 pieces in each. And then 1/8 is the last one. Okay, so we are taking away 1 whole and 3/8. Okay, so I'm going to go ahead and just shade all these in to show that these are, that the whole thing is what we're looking at. So there's 2 holes, so 3 holes, and then 1/8. So only 1 piece needs to be shaded. Okay, so I'm going to take away 1 whole and 3/8. Let me get a eraser. My knee just popped. Okay, so I'm going to take away 1 whole. So let's take away 1 whole from that. Then I need to take away 3/8. So I'm going to take one of these pieces, so basically that whole thing's gone, and then 2 more of those. Well, it's kind of hard to do that. So I took away that one, and I took away that one. So now what I have left is 1 whole and 1, 2, 3, 4, 5, 6/8. Which will simplify to 3/4. Because 6/8, oops, their common factor that they have, their GCF would be 2. So that would simplify to 3/4. So that's really messy. Okay. Grace is taking 7/8 of a tablespoon of cold medicine 3 times a day. She must feel really sick. How much cold medicine is she taking in one day? So we're basically adding 7/8 3 times. So we're going to do this as 7/8 times 3. Just like in the last Google Meet, we put the 3 over 1. And we're going to leave this as improper just because we're doing improper and mixed next week. And I don't want to overdo this, especially since I can't be there live with you guys because of technology. So 7 times 3 equals 21. 8 times 1 equals 8. So we'll say that is 21/8. All right, so converting fractions and decimals, we have 33 hundredths. So the way we would, so this is a fraction, we're going to turn it into a decimal. So fractions and decimals are very similar. They're almost like they're cousins in a way. So 33 hundredths would be 33 hundredths written as a decimal. So we have our decimal, and then we put 33. And this tells me that we're stopping at the hundredths place, so 33 hundredths. And we're going to do a whole unit with that so you'll know what place is which. So 33 hundredths would be decimal 33. And then the way you read 0.85, you would read that as 85, and then you're in the hundredths place, so that would be 85 hundredths. 85 over 100 as the fraction. Okay, comparing the decimals is not very difficult. However, it's easy to mix up if you're trying to go too quickly. Okay? Okay, so we have 30 hundredths compared to 3 tenths. Now, see there's a 0 here in the hundredths place. It's basically there's a 0 here too in this hundredths place, because this is like saying 3 dimes, and this is like saying 3 dimes. So I know that these two would be equal. Now here I have 49 hundredths, like 49 pennies, and then 5 tenths. But think of 5 tenths as like 5 tens. It's like 50 cents. So it's like I still have that ghost 0 there, where I'm comparing 49 to 50. So 49 cents would be actually less than the 50. Okay, and on the last, label the lines below as perpendicular and parallel. Now the format of this got a little strange, so I'm sorry if it didn't really quite work out very well. But parallel, if you remember back from November and Christmas, parallel are going to be 2 lines that will never touch. They will never intersect. So I know that the 2 lines that are like making 2 L's, kind of like the word, like the letters L in parallel, are going to be parallel lines. Now perpendicular are 2 lines that when they intersect, they're going to make a right angle. So that intersection where these 2 lines cross, we have created a right angle, meaning that it would be perpendicular if you see that like T. It has that, looks like it's a letter T in a way. So that would be perpendicular. So let me see if I can type on my paper here. Oh, I can. And let's see, in parallel, in parallel is that one that's kind of floating in the air. Okay. All right, almost done with our spiral. So the next, that Thursday section is less than, greater than, or equal to. Find the sum you can do, find the product. Let's see, there are 4,387 trees in the state park. After a strong storm, 799 trees fell down. How many trees are there now? So think about if you are starting with a number of trees and then you take some away. If they fall down, they're gone. You're going to take those away. Think what operation that is, and that's what I want you to do for that problem. All right, least common multiple. I don't think I ever really talked about this. I think maybe one time introduced it. It's really more of a 5th grade skill, but it doesn't hurt to be familiar with it now. Least common multiple is going to be the first multiple that the two numbers have in common. So multiple, remember, is when you are skip counting. When you are, like skip counting is like 2, 4, 6, 8, 10. So we're looking for the first one that those two have in common. So if I start here, I have a 2, because 2 times 1 is 2. First multiple of 7 would be 7. So far, none in common. Next one for 2 would be 4, because 2 times 2 is 4. Next one for 7 would be 14. Next one for 2 would be 6. Next for 7 would be 21. I see I still do not have 1 in common. Remember, 2 times 1, 2 times 2, 2 times 3, 7 times 1, 7 times 2, 7 times 3. Next would be 8, then 28. Still nothing. Then 10 and 35. Nope. 12 and 42. No. 14. Oh, look here. Got those 14s together, so we know we got it. So I'm going to list my multiples for 2. We'll say the LCM, or least common multiple, equals 14. Okie dokie. All right. Ugh. So now we got 5 2/3 plus 5 2/3. Okay. So we're going to add our whole numbers first. We got 5 plus 5, which would give me 10. My denominators are going to stay the same as 3. And then we're going to add the numerators 2 plus 2 to get 4. So we have 10 4/3. Now, let's go ahead and make that into a proper fraction. So I know that 3/3 would be the whole because 3 is my denominator. So if I take that whole out and give it here to the whole number, then I have 1/3 left. So I know it would be 11 1/3. Okay, we're going to skip that subtraction one just because I know when these videos get too long, it is hard to stay focused. So we're going to go ahead and skip that one because we will learn more about that this week. 4 students each run 5/6 of a mile in PE class. How many miles do they run altogether? So we're doing 5/6 times 4. Once again, you're putting 4 over 1. We're multiplying straight across. So 5 times 4 equals 20. 6 times 1 equals 6. So we have 26. Multiplying fractions will be soon, or we'll turn improper to mixed. Okay. Convert. So here we have 400. So if you remember from earlier, the hundredths place is that second spot after the decimal. So the 4 is actually going to go in that hundredths place because it says 400ths. So in this tenths place, since there are no tenths, doesn't have a 1 or a 2 in front of it, we're going to put a 0. So it's almost like 4 pennies out of 100 pennies, like 4 cents to make 4 pennies. It's actually pretty easy. I like decimals can make things pretty easy. All right, so now here we have 0.3. So since this is the hundredths place, this one is the tenths place. So we are going to say the 3 first, 3 tenths. So this would, decimal 0.3 would actually equal 3 tenths. So 3 tenths. All right, oh, these next few ones Should be super easy. And I'm actually going to let you try those on your own. Think of that like money. If you have $4.39 to $4.28, think what the symbol would be in the middle. Or $5.55 to $5.85, think what the symbol would be in the middle. It makes it a little bit easier. Okay, the geometry review has been a little rough. Have some people with 100s, some forgot geometry, so that tells me I need to review it. Oh, I spelled parallel wrong on this side over here. Okay, so we're looking first for the shape of two sets of parallel lines. So two sets, remember parallel are two sides that are never going to intersect. They're never going to touch. So I see that this one has one set of parallel, but then these two would intersect at some point. But then I see that these are parallel, so there's one, and here's two. So I would say one parallel, two parallel. So the rectangle would have the two parallel shapes. I might just move the shape where it belongs. And then box the shape with two obtuse angles. How about we just move that shape that would have two obtuse angles? So obtuse, if you remember, we have right angles, you have acute. Obtuse is going to be bigger than those right angles, the big old fat angle. So we're looking for which of our shapes had two obtuse angles. Okay, well these angles are all teeny tiny small angles. So I would say those are acute, so not that one. If I look here, there's an obtuse angle, there's an obtuse angle, so I bet it is the upside down trapezoid. And so the triangle is not one of our answers, so I'm just going to delete that one and then move that other one right below it. Okay, so there is the spiral. It will be, the ones that we did together, I will have downloaded for everyone, even if you weren't going to be able to join the Google Meet, just because of my technical difficulties. So now I wanted to show you a few things with adding, I about dropped my whiteboard. I wanted to show you a few things with adding and subtracting fractions. You should have a pretty good idea based on your spiral how to do these. But so say we had 3/8 plus 1/8. Okay. Now when you're adding those, the denominator is going to stay the same. Now we've talked about that, but we haven't said why. So think of it like this. Let me draw 3/8 first. Okay. So I made 8 for my denominator. And I'm going to shade in 3. 1, 2, 3. If I add just 1/8 to that, that's just one of these little pieces because 1/8 is still how many pieces are in my whole. So I'm just going to shade in one of those pieces. So now look what I have left. I still have 8 as my denominator. So that has not changed because the number of pieces in the whole has not changed. But my numerator will now be 1, 2, 3, 4 because 3 plus 1 equals 4. Now, you are expected to simplify whatever answer you get. So 4/8, you have to think back to your simplifying rules. So I know in rule 1, if the numerators half the denominator, then it equals 1/2. Is 4 half of 8? It is. So I would say 4/8 is actually equivalent to 1/2. So 1/2 would be the answer I accept. The adding part was easy. You still have to simplify. That's what usually tricks people. Okay, let's do another one with just normal old fractions. Okay, let's do 3/12 plus 5/12. When you get to 5th grade, Miss Laird will teach you how to add fractions that have different denominators, and you're going to use a lot of equivalent fractions and stuff that we learned in 4th grade to help you with that. So we want to make sure our fraction knowledge here is pretty strong, or at least something she can build off of. Okay, so Once again, our denominators are staying the same. Let's see why. I'll do 6 on this side, 2. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. A great resource to use to show adding fractions are those fraction tiles that I've shown you before. It does help to use those as manipulatives to see why the denominator is staying the same. So 3/12, my kids in class are going to be using them too. So I want you guys to, it's still on the wall, the stream for you to use. So 3/12, I'm going to add 3, 1, 2, 3. So I have 3/12, and now I'm adding 5/12. So I still have 12 in this hole. I'm just going to show 5 that are shaded. 1, 2, 3, 4, 5. So I just added 5 more to the hole. So now I look and I have 12 pieces are still in that circle making the hole. And I have 8 pieces that are shaded. Now, once again, 8/12 can be simplified. And I believe for the virtual learners, I told you which ones to simplify because that is kind of tricky. 8/12 can be simplified, so we are going to have to simplify it. I know 8 is not half of 12. 8 cannot divide into 12, so I'm going to have to do the GCF. So I'm going to list my factors. 1 and 8. 2 can divide into 8, so 2 times 4. It's hard to see. And then for 12, I've got 1 and 12. Let's see, 1 times 12, then 2 times 6, and then 3 times 4. So everything in 4th grade builds. If you don't understand one concept, when we move on to the next, you may already be behind. So make sure you're really learning how to do these skills and you're not forgetting them from week to week because they build and they build and they build. And it's going to keep building. That's just how math is. You have to master the skill before in order to master the new skill. So make sure you remember those simplifying. All right, so if I look at these, I see that the factor they have in common, so they have a 1, 2, it would be the 4. So I'm going to take the 4 and divide them both by 4. 8 divided by 4 would equal 2. 12 divided by 4 equals 3. So 2/3 would be my simplified fraction. Okay, so I wanted to show you 2 more new skills we're doing this week. This week has a lot of new, but a lot of it are things that you've heard before, so it's not anything that's brand new, but it is a lot of new this week. So adding, subtracting mixed numbers with regrouping, same type of thing. We're leaving the denominators alone. Let's do an addition. Okay, so if I'm adding these 2 fractions, we always start with the whole number first. I have 4 wholes plus 4 wholes, so like 4 whole cookie cakes plus 4 whole cookie cakes. 4 plus 4 would equal 8 whole cookie cakes. The denominator will stay the same, so the 3 does not change, and you just add the numerator. 1 plus 1 would equal 2. Now, like we did earlier, say it was 2/3 plus 2/3, and you got 4/3 as your answer. Well, that looks kind of funny. It's an improper fraction. So what you can do is take 3/3 out, which is 1 whole, and give it to that 8. So it's kind of like you're regrouping with addition, where you have 10 and you give it to the next one, except it's using fractions. So I've taken a whole out, and I'm going to give that to the 9, and we're doing this next week too, so with improper mix. So don't think that you have to have it mastered just yet. If I took 3 away from the 4, I'm going to end up with 1/3 left. So that would give me 9 and 1/3. Just smacked myself. Okay, let me show you with subtraction. This is a good one to maybe try drawing it. We're going to be doing that in class, but I'm going to be using some tessellation blocks where they'll see the fractions actually being taken away. So say we had 4 minus 2 and 1/2. Now, a lot of people want to say 4 minus 2 is 2 and then the 1/2. No, I don't. You can't. I could do 4 minus 2 is 2, but then 0 minus 1/2, you're going to have to borrow it from somewhere. So this is a great one to draw out. And when we get to improper mix, you can do other math ways to learn it too. So let me draw 4. We'll say cookie cakes again because I'm hungry. Even though I just had lunch, I'm hungry. So 4 cookie cakes. And we're going to, even though there's not a fraction here, it's understood that that denominator is how many pieces are in the whole. So that tells me that there are 2 pieces in each whole. So I'm just going to split these in half. And I know that it's like they're all shaded because it's all 4 cookie cakes are there. Okay, so now let's take away 2. So I've taken away 2, and now I have to take away a half. So instead of taking away a whole thing of here, I'm just going to erase one of the ones that I colored in. So now I have 1 whole and 1/2 left. Boom. Okay. Last thing to show you that you'll be doing this week is turning improper to mixed. I've shown you a little bit with that. You'll do more with it next week. That's the big thing we're learning next week. So say you have a fraction where the numerator is bigger than the denominator, 9/2. You could draw this out. Drawing this one is a great thing to do, especially if math is something you struggle in. So I know that 2 pieces are in the whole. But I know I have to have 9 pieces colored. So I got 1, 2, still got to color 9, 3, 4. Remember, 2 pieces are still in a whole, so each whole will be cut into half. So 1, 2, 3, 4, 5, 6, 7, 8, almost there, 9. So I have 9 shaded halves. Let's see what this would be as a mixed number. So we're turning this into a mixed number. I have 1 whole, 2, 3, 4, and then you have that 1/2. So this would equal 4 and 1/2. If you're not into drawing it, and sometimes the drawing might take a really long time to do, you can also use division. When the bigger number's on top, and it has 9 divided, this is like a division symbol here. You're saying you're dividing 9 divided by 2. So, and I'll do another example of this. Let's divide 2 into 9. I know that 2 will divide into 9 4 times. 2 times 4 equals 8. 9 minus 8 equals 1. Nothing to bring down, so I have remainder 1. So this here will tell me the whole number. So that's your whole. And then the remainder is the 1. And the denominator stays the same. It does not change. So 4 and 1/2. Let's do one more. I know I've been doing this video for quite a while. But it's recorded, so you can rewatch whatever you need to watch. Let's do 10/3. Let's turn that into a mixed number, or let's see how many wholes that is. So let's draw it out first. 3 pieces make the whole because that's our denominator. So in 1 whole, I'll have 3 pieces. I need to shade 10. 1, 2, 3. Okay, so I need to shade 10, so I've got to keep going. 4, 5, 6, 7, 8, 9. Need 1 more. 10. Okay, so by coloring it, I see that I have 1, 2, 3 holes, and then 1/3 left over. So 10/3 and 1/3, 3 and 1/3 are equivalent to one another. It's the same thing. All right, if I wanted to check that with division, all right, so 3 divides into 10 3 times. 3 times 3 equals 9. Subtract 10 minus 9 equals 1. Remainder 1. So 3 is my whole, 1 is my numerator, and 3 is my denominator. Okay, so We will try to do a Google Meet again next week now that I think I know how to fix it when my camera's not working. I'm so sorry if you logged on and I wasn't there. Just had some technical difficulties. So if you need any help this week, please let me know. You guys are good about asking questions during those Google Meets. I will try to get back to you as soon as humanly possible. So have a great week. Enjoy the beautiful weather and don't forget to simplify.